Let's continue on with our functions. Let's look at f of x equals x cubed. So again, I'm hitting that table feature on my calculator. I'm clearing out anything I have. I hit x, then I hit that little caret button, that little arrow that points up. It's right above the x squared button. And then I hit 3 and I hit enter. I want to start at -5, hit enter. My step is 1, hit enter. Make sure auto is selected and then hit OK. When I do this, I'm going to see a ton of values here. For instance, when I'm doing this, I'm looking at x and I look at my y values, I see a -5 and a -125. That is not even close to being on this graph. I need to make sure that I have my y values between -5 and 5. So I'm just going to scroll down and keep on hitting down until I see a value that's actually going to be there. The first value that I actually see there is -1, 1. That's the first one that would actually be in the window. -2 is -8, but that's still not in the window. I see a number 0, 0. I also see a number 1, 1. And then 2, 8, that's not in the window. So it looks like the only 3 points that I can plot on this one would be -1. Sorry, it's -1, -1 is what I meant to write. -1, -1. So here's the point -1, -1. Here's the point 0, 0. Here's the point 1, 1. Those are the only 3 points that I have, and I need to label at least 3 points, so those are the 3 points that I'm going to label. But I really want you to be careful with what does this graph look like, because if I look at just those 3 points, it looks like I would connect them with just a line. So I also want you to consider, I know we can't graph it because it's not in the window, but consider that point 2, 8. That would be clear up here, even higher than that, okay? And that point -2, -8 would be clear down here, way, way, way down that way. So we need to make sure that we're accurate within the window and make sure we remember what does the shape of x cubed actually look like. Well, x cubed has a curve to it, and it looks something like that right there. So we've got to make sure we're accurate within the window. I'm going to do the same thing over here, estimating what would it be like if I went in the downward direction. So it's kind of like this S-looking shape is what I like to say. I don't know why, but kind of looks like this S-looking shape right there. So again, domain and range, domain being how far left do I go and how far right do I go? Well, if we expanded this out forever, it would go all the way left, which is -infinity. It would go all the way right, which is +infinity. Range again being how far down and how far up does it go? Well, this graph would definitely go all the way down. This graph would also go all the way up. So the range on this most certainly would be -infinity all the way down to infinity all the way up. Increasing and decreasing is the x values. As I go from left to right, is my graph going up or down? Well, notice as I go from left to right, I'm always going up. That means I'm always increasing. So how do I write that? I write -infinity to infinity. Decreasing. Where do I go down? Well, this graph never goes down, so the answer would be none. It does not decrease. X-intercepts, where does it touch the x-axis? It touches at the point 0, 0. Y-intercepts, where does it touch the y-axis? It touches at the point 0, 0. So there's our function and graph and analyzation of x cubed. Let's now look at square root of x. Square root of x, we need to put this into our table in our calculator. So I'm going to hit table. I'm going to clear out anything that's there. I need to hit the square root button. The way that I do that is hit second and then x squared. You'll see the square root symbol. And then you hit x, enter. Make sure you're starting at -5, enter. Step of 1, enter. Auto, enter. Hit OK, enter. Okay. And if you notice, when I look at this, here's what I'm seeing right now. When I see x and I see y, when I see -5, I see the word error written. Why is there an error? That means it's not part of the domain of the function. If you remember, square root of x is only defined at numbers from 0 on. So keep on scrolling down and we'll see that when we see a 0 for x, we also see a 0 for y. When I see a 1, I see a 1. And then let's pick some other numbers here. When I see 2, it's a really nasty number, 1.41. 3, 1.73, bad numbers. So I'll put another good one that I see. How about the number 4 and 2? 5 is a 2.23. That's not a nice number either. So those are 3 nice points that I can use. And remember, I only have to plot and label 3 points for sure. So there's 0, 0, 1, 1. Another point that I want is the point 4, 2. I'm going to go ahead and label those. 0, 0, 1, 1, and 4, 2. And now I'm going to remember what the graph of square root of x looks like. Square root of x is a nice curved graph, kind of like a parabola, but flipped on its side. Looks something like that right there. So let's ask our questions. Let's look at domain. Domain, again, is how far left does it go and how far right does it go? Well, the farthest left it goes is to x equals 0, and then it goes all the way to the right. So how would we write that? Well, it goes from 0, goes from 0 all the way to infinity. We know infinity has to have a parentheses. Again, the question is it an actual point when x equals 0? The answer is yes, so I'm going to use a bracket. Range asks me how far down and how far up do I go. So for the range, how far down do I go? Well, the lowest y value I see is y equals 0. How far up would this graph go? Well, if I went to the right, this would go all the way to infinity. So what's the range of this graph? Just like the domain, it's going to be bracket 0, comma, infinity. Now the question is, as I go from left to right, what is this graph doing? Is it going up or down? That's increasing and decreasing. Well, as I go from left to right, no matter where I put my pencil, or in this case a pointer, it seems that I'm going up. So that means I am always increasing, but notice what's my x value that it starts at? It starts increasing at x equals 0, and it goes all the way to the right, which is infinity. Where's this graph decreasing? Does it ever go down? No, it doesn't, so that's none. X-intercept, it touches the x-axis at the point 0, 0. Y-intercept, it touches the axis at the point 0, 0 as well. That origin, it's huge x-intercept and y-intercept for all of these basic graphs if you haven't figured it out. Let's keep on going. Cube root of x. Well, how do I put the cube root of x into my calculator? If you notice the second arrow button, you actually do have a radical where you can put in the cube root of x. Or another trick, like we learned in the algebra review packet, is I could always write this as x to the 1/3. So if I want to put this into my calculator, I could put the cube root of x or x to the 1/3. It doesn't matter. But go ahead and do that now. Hit the table feature. Clear out what's in there. I'm going to do an x, the caret button, and now I'm going to hit the n over d for a fraction, 1, and I'm going to hit down and hit 3. So that's how I put x to the 1/3 in my calculator. The x, the caret button, that arrow pointing up, I hit the n over d for a fraction. I hit 1, hit the down arrow, hit the number 3. Hit enter. We're going to start at -5, hit enter. Our step is 1, hit enter. We want auto, and we want OK. Let's start looking at this and see if there's any nice values for us to put in. -5 is -1.7, not a nice value. -4 is -1.58, not nice. -3, same thing. -2, same thing. But finally, I'm seeing some decent values. At -1, I see -1. At 0, I see 0. And at 1, I see 1. So that's 3 nice values that I can use. So that's 0, 0, -1, -1, and 1, 1. Let me go ahead and label those because we got to label at least 3 points on our graph. So there's my 3 points that I've labeled right there. I want you to notice, if you look straight above us, these are the exact same 3 points as x cubed. But this graph is hugely, hugely different, and you need to know that. So for instance, when I look at -2, what's the value here? -2 is -1.25. So that would be something, I'm not going to quite put it up, but that would be something like this dot right here. -3 is -1.44. So that would be something like this dot right there. -4 is -1.58. So it would be just something like that there. -5 is -1.7. So that would be something like this right here. Same thing would happen if I go to the right. I would notice that in the window, I never go above the y value of 2 or below the y value of -2. So my function looks a lot like x cubed, except flipped on its side. Instead of going up and down, it goes left and right. So there's I touched the ends of the graph. I'm accurate. I've labeled 3 points. Let's ask ourselves our questions again. Sorry, for domain, what's going on? Domain is left to right. Well, this graph would go all the way left, so that's -infinity to infinity. The range question looks a little difficult on this one. The range is how far down would this go? Well, if I extended all the way to the left, it would go all the way down. If I extended all the way to the right, it would go all the way up. So again, my range on this problem is -infinity to infinity. As I go from left to right, what's happening? Well, as I go from left to right, my y value is always going up, which means I'm always increasing, and that happens from -infinity to infinity. My decreasing, when does this graph go down? The answer is none. It never goes down. X-intercepts, where does it cross that x-axis? At the point 0, 0. Y-intercepts, it crosses at 0, 0. Let's move on to the last function for this page, which is f of x equals 1 over x. This is called the reciprocal function. This is a fraction. Something I know immediately is that I cannot plug in x equals 0 because x equals 0 would be undefined. So the domain of this function is restricted. Just like the square root of x has numbers you can't put in it, the reciprocal function also has numbers that you can't put in it. So let's go ahead and use our table feature on the calculator. Hit table, clear out whatever's there. I want you to hit the n over d button, which gives you the fraction. I'm going to hit 1 and then down, and I hit the x. I hit enter. I make sure I start at -5. I stop at 1. Step is 1. I have auto selected, and I hit OK. When I do this, I'm going to see a bunch of fractions. I'm going to scroll down to see if we can get any nice numbers. I definitely see a point when I'm looking at this. I'm looking at my x and y values in my chart. I definitely see a point of -1, 1, and I also see a point of 1, 1. The rest of them are fractions, and I do need to label at least 3 points, so I am going to have to label at least 1 point here with a fraction. But the one thing that I did want to point out is when you see 0, you see error, and that means we can't plug in the number 0. Again, we already discussed this. That would be division by 0, which is not defined. So let's look here. We have -1. Sorry, when we plug in -1, we get -1. I forgot my negative sign there. So we have our first point of -1, 1. I'll label that. And we also have another point of the point 1, 1. Okay. And I need to see what's actually happening to the behavior of this graph as I go on. So if we keep on going, there's another point that we could plot. How about at 2, 1/2? Or you could have done -2, -1/2 would have been 1. But as you go to the right, it looks like your y value is coming from on top of 0 and getting closer and closer to 0. And as you go to the left, it looks like your y value is getting closer and closer to 0, but staying below 0. So my function looks something like this, where it's going to come in from the right, come in from the left, but the question is what happens as it approaches 0? So we could also plug in values. Just go ahead and try, if you want to go back, you could go into the ask feature where we set it on auto. You could go back to your table and change it to ask. Try plugging in something like 1/2. 1 over 1/2 is actually 2, so the point would be 1/2, 2. If I plugged in 1/3, that would be 1 over 1/3, which is 3. So 1/3 would actually go up to 3, 1/4 to 4, 1/5 to 5. So as I get closer and closer to 0, from the right, it looks like I go up towards infinity. Same thing, if I plugged in -1/2, that would be -2. If I plugged in -1/3, that would be -3. And as I get closer and closer to 0 from the left-hand side, it looks like I approach -infinity. Again, you could just use the ask feature on your calculator, or you could do analyzation yourself. So what actually happens when x equals 0? Well, if you looked at this graph, a lot of different calculators or graphing tools would actually graph a dotted line there, a vertical dotted line at the line x equals 0. That is called a vertical asymptote. That is a vertical asymptote. Likewise, we actually have a horizontal asymptote as well at y equals 0. It approaches but never touches that value as you go to -infinity and +infinity. So those are called vertical and horizontal asymptotes, which is something you should have learned analyzing rational functions. So let's take a look at this. This one we got to be really, really careful with. Let's go back to our domain question here. Domain, again, is how far left, how far right. So if I look how far left this graph goes, it goes all the way to -infinity. How far right does this graph go? Well, this graph would go all the way to infinity. But there is something that I have to worry about. I have to worry about excluding x equals 0, because it is not defined when x equals 0. So what do I do for that? How do I write that? Well, think about that number line. We would go from -infinity to the number 0, and then you could put that u there. That u means union. You don't have to, but you have the u there, that's union, and then you would also start back up 0 and go to infinity. So that's how you write every number but 0 in interval notation. Let's do that range. Think about that range again. Range, again, is how far down. Well, the graph clearly goes all the way down to -infinity. How far up? That graph clearly goes all the way to infinity, but yet again, we cannot include that value, y equals 0. So how do we write that? Again, we would write it from -infinity to 0, again going down to up, union 0 to infinity. Increasing. Where is this graph increasing? Well, as I go from left to right, if you notice, I'm always going in a downward direction. Even when I go from 0 to the right, I'm still going in a downward direction. So where is it decreasing? It's decreasing everywhere except x equals 0. So again, how do we write that? We would write that as negative infinity to 0, union 0 to infinity. You don't need the union symbol, I just put it here. Increasing. Where is it increasing? The answer is none. Where does it touch the x-axis? Well, it actually never touches the x-axis, so there's no x-intercept. I'll just write none there. Where's my y-intercept? Well, it never touches the y-axis, so again, I'm going to write none there.